Okay, so in this lesson, part 4 of Introduction to Polynomials, we're still discussing simplifying polynomials by combining like terms, but this time the polynomials will have multiple variables. So in the previous lesson, there was just the same variable. So meaning that each polynomial, see, they had just the variable x, Here, this variable was just x. This variable here was just s. So no other variables were involved in this. It was just the same variable. And then you had a constant term, possibly. So in this lesson, though, the polynomial will have multiple variables. And so what I mean by that is this. So you look at this example. So this example, this term has two variables, a and b. So instead of one variable, it has two variables. So if you look at this polynomial, the terms contain a's and terms contain b's. All right, so remember, just as before, you want to simplify the polynomial by combining like terms. Now, in the previous lesson, if you recall, we tend to put the polynomial in descending order. Now, we tend to do that in descending order if there's just one variable. All right, so if there's just a variable x, we put in descending order. If there's just a variable s, we put in descending order, and so on. In this case, though, since there's not just one variable, there's more than one variable, we're not going to put it in descending order. All right, we're just going to list the terms. All right, so the way I would do this is this. I would start with the first one and look at the variables. So the variables are a to the first, b to the first. And the question is, do I have any other terms that's a like term to it? So in other words, are there any other terms that have the variables a to the first, b to the first? And the answer is yes. There's this. So that means that this and this are like terms. All right. Now, it did not matter. You could have started with the a's first. It does not matter. All right. So since there's more than one variable, we're not discussing descending order. So the order in which you put this is not going to matter. So 3ab and 6ab, so 3 plus 6 is 9, so I'm going to get 9ab. All right, and then we have these two terms that are like terms. This term has a to the first, this term is a to the first. Now remember though, if you have trouble with your signed numbers, see -4 plus a -7, use your calculator. But -4 plus a -7 is -11. And so we're going to say 9ab minus 11a. All right? And that's it. Those are not like terms. So all of a sudden say this is -2ab. Those are not like terms. This has ab. This is just a. Okay? So there's your answer. And number 2. So number 2, notice that this polynomial has both x and y. Again, since there's multiple variables, let's not discuss descending order. So I'm going to start with the first one I see. The first one I see is 4x squared. The question is there any other term that's like terms with it? So in other words, do you see a term that only has x squared in it? And the answer is no. So I'm just going to go ahead and list it. So therefore I have 4x squared. Okay. Now my next one is 6xy. So is there any other term that's alike with it? And the answer is yes. There's this one. All right, so I'm going to underline these. So these are like terms right here. This is a -6. This is a -1. And so -6 and the -1 is a -7. So that becomes 4x squared minus 7xy. And the only term left over is 3y squared. So just rewrite it. All right, so there's your answer. All right, those are not like terms anymore, so you're done. Number 3. So notice number 3, again, you have x's and y's. So you have multiple variables. Again, start with the first one. X squared y. Is there any other term that I can combine it with? So in other words, do you see another term that has x squared y to the first only? So this is not like terms because that's x to the first. I want x squared y. So not this one. Now, look at this one. So it's not this one either because that's a constant, and this is y squared x. But I want you to notice something. So remember, multiplication is commutative. So some students will look at this and say, well, they're not like terms because this is x squared y and this is yx squared. But remember, multiplication is commutative. 6 times 7 is the same as 7 times 6. So x squared times y is the same as y times x squared. Okay? Now, I'm going to go ahead and do this. I'm going to go ahead, because if I combine these like terms, that's going to be 0. 5 and negative 5 is 0. So I didn't want to do that. Let me just make this a negative 8 right here. Okay? Just change this to negative 8. All right, so 5 plus a negative 8 is a negative 3. All right. Now, if that was a negative 5, you wouldn't even list it all because those two terms cancel out. All right, so you wouldn't have it listed. But I just want to put it listed, so I changed this coefficient. So 5 and a negative 8 is negative 3. So I get negative 3. And I'm going to go ahead and, when we write the terms and there's more than one variable in the term, we put in alphabetical order. So I'm going to put x first. So it'll be x squared, y. So these two terms are alike. 5x squared y and a negative 8yx squared is a negative 3x squared y. All right, now the next one I see is this one. Is there another term that has xy squared in it? So xy squared, and the answer is yes, right here. Remember, multiplication is commutative, so xy squared is the same as y squared x. So this is a 6, this is a negative 9. 6 and a negative 9 is a negative 3. So I get negative 3x squared y minus 3xy squared. Okay? So again, put in alphabetical order. So xy squared and y squared x is 6 of them, and then negative 9 of them is a negative 3xy squared. And it looks like the only thing left is just constants, so say plus 4. So there's your answer. If you can't combine those, don't make a mistake and say these are like terms. Remember, yes, they both contain the variable x and y, but the issue is the exponent. This is x squared, and this is x to the first. This is y to the first, this is y squared. Okay? All right, number 4. All right, so number 4, you have, let's see. All right, you have this polynomial. Again, let's start with the first one. Y cubed. Is there any other term that has y cubed in it? The answer is no. So I'm going to go ahead and just rewrite it, 14y cubed. The next one I see is a constant. Now, again, I'm going to put the constant last. So let's just deal with the constant last. We always tend to put the constant last anyway. So let's go straight to this one. A squared b squared is another term that has a squared b squared in it that's alike. And the answer is yes, because that's b squared a squared. So remember, multiplication is commutative. So this is a positive 3. This is a negative 19. 3 and a negative 19 is a negative 16. So I get 14y cubed, and then when I combine these two, I'm going to get minus 16a squared b squared. And now let's talk about the constants. So a negative 9 and a negative 10 is a negative 19. And you're done. Now, again, these are not like terms, so you're done. Again, we're not talking about descending order here, since they have multiple variables, but we still put the constant last. Okay, number 5. Again, let's start with the first one. AB, is there a term that I can combine it with? In other words, do you see another AB anywhere? The answer is yes, right here. AB and BA. All right. So their multiplication is commutative. Now, this is 11 AB. This is a negative 1 AB. 11 and negative 1 is a positive 10. So again, these two are alike. So 11AB and a negative 1BA is going to be 10AB. Again, put it alphabetically. Now, if you wrote this as 10BA, it's nothing wrong with that. 10BA is the same as 10AB, but we tend to write it alphabetically. Put it alphabetical order. All right, the next one I see is a squared. Is there another term that has a squared in it? The answer is no. So I'm just going to go ahead and rewrite it. And the only thing left over is b squared. So just go ahead and rewrite it. Okay? So there's your answer. Now, those are not like terms, so leave them alone. Number 6, again, let's start with the first one. X squared y squared is another term that has x squared y squared in it. And the answer is yes, right here. Xy squared, x squared, y squared, y squared, x squared. Okay, multiplication is commutative. The order in which you multiply does not matter. Okay, now let's look at the coefficients. This is a 7. This is a negative 4. When I add them, I get positive 3. So far I have my answer is 3 x squared, y squared. My next one is y squared. Do I have another term that I can combine it with? And the answer is yes, because this term only has y squared, and this term right here only has y squared. So 2 and a negative 1 is a positive 1. So when I rewrite it, I just say 3x squared y squared plus y squared. Okay, now next one I have is x squared. So this term and this term are alike. So 1 plus 5 is 6. So 1x squared plus 5x squared is 6x squared. And so there's your answer. Okay, and then finally number 7. So it's not a difficult lesson. It's pretty simple to deal with. The next one, again, multiple variables. So you have, let's start with the first one, xy. Can I combine it with anything else? So I gotta find one that has xy in it. So that's not it, but here's one. Is that all of it? Here's another one, and that's it. So there are 3 like terms here. So I'm going to say 4 plus 8 plus 4. And so 4 plus 8 plus 4 is 16. So 4xy plus 8xy plus 4xy is 16xy. All right, now the next term, x squared y. Do I see another x squared y? Yes, right here. And here's another one. So there are 3 terms of those I can combine. So x squared y, x squared y. Oops, that's not it. That's xy squared. Sorry. So there's only 2 now. So x squared y, x squared y. So this is a negative 6, and I'm adding a negative 1. So negative 6 and a negative 1 is a negative 7. So this becomes 16xy minus 7x squared y. And then finally, it looks like this term, xy squared, and this term I can combine. And so this is a positive 3. This is a negative 10. I didn't have enough room, so that's minus 10xy squared. So that's minus 10. So 3 and a negative 10 is a negative 7. So this becomes negative 7xy squared. And that's it. Now, be a little bit careful. So you may say, well, all those are like terms because they all contain x and y. Yes, that is true. They all contain x and y, but they're not like terms. Because remember, like terms have to have the same variables, which they do. They all have an x, they all have a y, but they have to be raised to the same power, meaning that all the x's have to have the same power, all the y's have to have the same power, and they don't. This is x to the first, this is x to the first, y to the first, this is x squared y, this is x y squared. So none of them are alike. So you're done. Okay, so that's going to take care of this lesson. So it's not a difficult lesson. It's fairly simple, but to simplify polynomials, just like in the previous lesson, you can combine like terms. And since there are multiple variables, we tend to not talk about descending order. All right, so we tend to only put polynomials in descending order if it has the same variable. Okay, so that's the end of this lesson.